Alrighty, it's recording.
Alrighty, everyone. Welcome and thank you for coming to the Engineers Week to support SHIP Region 6. And we're all here to look at the engineering problem-solving process today. So SHIP Illinois Tech will be co-hosting this event with SHIP Region 6, but we just like to thank them for all the resources they provide for us and also for all of you out there tuning in today. So here's some pictures of SHIP Illinois Tech. We're located at 35th Bronzeville IIT Green Line stop, and we're located right across the White Sox Stadium. So if any of you want to stop by next year when COVID is a little bit more cleared up, you can drop by. So here's a couple of pictures from pre and in COVID. Didn't want to say post-COVID yet because we're still in it, but yeah, we're all very fortunate to be able to communicate virtually like how we are tonight, and we're very glad to have everyone here today. So a little bit about what we'll be talking about tonight is the introduction to engineering problem solving. And so as all of us are engineers and all of us are aspiring to solve problems about the real world, some things that we forget, I feel, is actually why we wanted to become an engineer. And so revisiting some of can help out in refocusing your career path or even asking the right questions in interviews or different types of professional development workshops. So looking at the different ways that an engineer can solve a problem, we may be technically versed in all of our college career, but being able to apply those into the real world is definitely a great tool. So today we'll be talking about two current day problems that are pretty global and have an impact on our everyday lives. So this is just one tool that you can use in order to really make a difference and try to think about how you can impact the world, how your job impacts the company, or how you can make a greater impact on the world through your engineering career. There's a lot of engineers that came before you and a lot more to come. So it's definitely a very prestigious job to have. And we're all here together to celebrate that in Engineers Week. So at the end, we'll be talking about an activity where all of you can participate in. And also we're free to be contacted later if you want to um, chat with someone and you're viewing this virtually. So now I'll introduce our external vice president, Eric Moy, who will be giving a presentation on this slide.
Hi, everyone. So why is the engineering process important? I think this quote sums it up pretty well. Scientists discover the world that exists, and engineers create the world that never was. Quote by Theodore von Karman, who won the National Medal of Science, famous aerospace engineer in the 1950s. And then what is the engineering process? I think some of you already know this, but I think it's good to review when you start internships or career and are assigned to work on specific projects. I think it's prevalent no matter what field you're working in. And the first step of the engineering process is to ask. And that's identifying what the problem is, the constraints that you have, and then the resources that you have available related to that problem. Next is research. So what you know about the problem, what concepts can you apply or think would be useful when coming up with solutions? And that would be the next step, imagine. And this is based off the research you've done, probably the most creative part of the process and requires like a lot of out-of-box thinking. You would have your list of solutions that you come up with based off what research you've done. And then once you have your list of solutions, you need a plan. So this is important in the real world because there are deadlines you would have to meet. So organization is key, and choosing what you need to work on as well. After you've chosen your idea to work on, which may be a combination of ideas or you just choose one idea, it'd be time to create your prototype, which would serve whatever function is needed indicated by your problem statement. You gotta think about your interim goal here. And then prototypes can be conceptual or physical as long as there's a way to test it. And that's the next step. So once you have your prototype or design created, you'd have to have a test plan where you can collect data and results to tell how effective your solution is. And then one of the interesting things about the engineering process is that it is a cycle. So once you complete it once, you have to do it over again. As you can tell from the circle here, so you collect all your data, you'd research again, imagine, and then plan your next prototype or solution.
So one of the biggest world problems that we have today currently is this little particle right here on the left, or on the screen, called coronavirus. And so for those of you who have been impacted by it or have had a lot of hardships, we definitely reach out to you right now, that we're always here for you to talk to us. But as engineers, we also have an actionable role that we can do to solve this problem. And so we're going to be talking a little bit more about this for a brief few slides, and have one of our breakout times for you to talk about it and definitely meet some other people here tonight. So going over this this map over here, this is a map of the different ways that the vaccine is being distributed right now. And so the vaccines, as you can see, have reached 1,753,000 people in California, in Illinois. It's 560,000 vaccines. And so there's a lot to be distributed, and it's a very big problem, that a very technical one that requires a lot of the expertise. And so engineers are just some of the people who can come into this kinds of process and solve it. Okay. So now, if you're tuning in virtually, you can maybe message a few people or talk to someone who you're living with, whether it be a roommate or a family member, just about how would you respond to COVID using your engineering major? What other engineers would you need help from? And what are some barriers and knowledge you are interested in learning about? So you can discuss in groups, and definitely this is a time for you to really think critically about how what you're learning in your classes can be applicable in the real world, and also to think about how all of us work together in order to solve big problems like this. Okay, I don't know if we're going to go into breakout rooms, but I think since, yeah, we'll be moving on after this. All right, and now we have our public relations chair, Asa Rodriguez, who will be we have our graduate chair, Hao, who will be presenting on this slide.
Hello everyone, I'm Hao, and well, the thing I like about engineering and science in general is the spirit of like collaboration. So everyone in different fields can come up and tackle problems around the world to make life better. And then from I'm a computer engineer, but we can talk about biomedical, chemical, and computer engineers and what they can do about COVID-19, of course. So for my biomedicals, well, this is a very recent field, but then they have this very hard task to develop models about how the COVID-19 transmit in the air, and then also developing studies about the virus, and of course the vaccines. For chemical engineers, they can relate a lot about processes, where they can improve processes about manufacturing the vaccine, the transport of them, and then all these stuff and different process in order to develop the vaccines. And well, as a computer engineer, we don't really do much about the actual COVID, but we can develop tools to keep everyone connected. So communications, 5G, communication platforms, Zoom, Teams, and all these kind of software tools, which allow us to well keep our lives in the same way that we have. And yeah.
Thanks, Hal. Yeah, definitely the world would be a lot different if this virus happened 15 years ago. So definitely a chance for you to learn about a couple of engineers for those of you who are high school students tuning in virtually. But the second problem that we'll be talking about tonight is, what is climate change? So climate change is another huge global issue that we have. And it's pretty much the input of carbon dioxide or greenhouse gases going into the atmosphere. And for those of you who don't know what climate change is, it's definitely okay. You can outreach to one of us here tonight and or read some scholarly articles online or YouTube videos about what it is. And so definitely this is one thing that will be impacted for future generations and definitely something that we all need to come together to solve. So climate change is the change from the norm of what weather year-round annual temperatures is. And so again, we'll have a little breakout time for how would you respond to global warming using your engineering major? And so what other engineers would you need help from? And what are some barriers and knowledge you are interested in learning about? So yeah, hopefully you can chat again with a friend or message someone or maybe a high school teacher or a college professor or someone that you want to talk to about this. But definitely it's something that engineers are tackling every day. And just to introduce a couple more engineers, on the left is the environmental engineer. They report like the impact of greenhouse gases into the environment and make sure like plants and animals are protected from deforestation or pollution. Deforestation is like when trees are cut down, or pollution, including air, light pollution, sound pollution. Electrical engineers are the people who are going to be designing your alternative renewable technologies or manufacturing electric vehicles in order for it to clean up the transportation industry. And agricultural engineers are people who study changes in average temperatures, rainfall, the climate, and the different types of pests and diseases that are affected because of it, and making sure that our food supply is very nutritious. And so for those of you who are high school students tuning in, a lot of these majors I personally didn't knew existed when I was in high school. And so it's definitely, hopefully tonight you'll be able to hear a little bit about a few that you could go into if you're interested. And now I'll be introducing Austin Rodriguez, who will be presenting on this slide.
Sure, thanks, James. So I'm a mechanical engineer. This is my 4th year at IIT. And so having considered all 3 of these majors when I was first pursuing engineering, I kind of know kind of their practices and types of things that they have to consider, as well as things that they have to go through on the day-to-day. Looking from a civil engineering perspective, they have to create the structures in which all the other things have to take place in. So looking to China, when they made the hospital in, was it like a few days? That was the job of the civil engineers in order to make sure that everything was up to code, everything was safe for people, and readily available for things to actually be brought inside. So they had to make those facilities readily available for people, and they had time constraints as well with it. Going on to industrial, this kind of is the managers, the engineering managers, the people that are kind of overseeing the engineers below them. They have to be kind of a jack of all trades and learn a lot of different skills and techniques in order to be able to provide the feedback to others to make everything flow nicely. So whether it's time crunching for vaccines or time crunching for being able to have machines up and running to assemble packages to be sent out, that would be the job of the industrial engineer in this case. And then moving on to mechanical engineers, they're kind of the missing piece, the puzzle piece that are able to bring it to fruition, the things that the industrial engineers are demanding. They're the ones that are creating the respirators, the ventilators, designing those in a way that's efficient and economical. And they're the ones that are kind of taking a small project and making it so that it can actually be put into practice later on. So you go from civil engineers, which is kind of, I think of like the top of the funnel, the big structures, going down to industrial engineering, which is the overseers, the one that are making sure that you're on time, you're doing what you're supposed to, and then down to the specifics of mechanical engineers, where they actually have to be hands-on and working with the actual technology, with the structures as well.
Perfect. So yeah, just to recap, a lot of the engineers involved in this process are pretty much just everyday people like you and I. And if we want to solve the global problems and global challenges, we definitely need to come together with a global brain. So in a pandemic and in global crises, a lot of times people may think about the negatives in the job market issues and the different types of challenges that come with it. But also by looking at the challenges that we're faced with today, there's a lot of more job opportunities and new companies that are taking action. And so giving yourself a chance to take a look at those types of situations are definitely something you can step back and see, oh, maybe this is some way I can give back. And so the activity that we'll be doing today is kind of something to meet other people, to mingle. And so you'll be broken up into groups in breakout rooms here in Zoom. And first we'll take 2 minutes to introduce yourself to each other. And then after, we'll be able to break out again and practice the engineering problem solving process. So as Eric mentioned before, it's ask, research, imagine, plan, create, test, and improve. And so the topic will be on the next slide. And so this 10 minutes, you'll be given to create one slide on Google Slides, and the slide will have different aspects of solving this problem. And we want you to be able to convey it with images. And so no more than 10 words on the slide, please. And after, a part of engineering is be able to communicate your idea. So we'll choose one member, you can choose one member from your group to present to the rest of us your findings. So the problem is, how would you yourself solve climate change? Would you reduce your emissions by walking more? Would you teach people about buying local? Would you make challenges in your student community to eliminate single-use plastics? So these are just some examples, but you can definitely go further on trying to figure out an energy audit for your campus dorm, or being able to reduce water consumption by changing faucets into, I don't know, better. Oh, and David put in the chat, smart grids, be able to modernize the electrical utility grid. So taking small steps in your daily life is something that we can all do, and together we can solve this global problem. And I don't know if we'll have time today with the group that we have to go over this, but for those of you who want to continue this type of challenge, there's also scholarships out there. So for college students who are tuning in today, or high school students looking at college, there's all these challenges online for a biannual $1,000 environmental awareness scholarship essay. So if you just want to take some time to jot down your ideas about using the engineering design process, you can get scholarships like this to help pay for your college. And for me personally, I kind of wasn't as hungry to apply for scholarships as I was my freshman year, but I'm still much in need of financial help as I was freshman year. So, but it's something to remember that besides your studies, you also should take advantage of these opportunities, and you have the Region 6 and your SHPE chapters to help you out with these types of things and to help you really get through college together. And so just to put in perspective, $1,000 may not seem like a big scholarship, but it's 90 hours of minimum wage work. So a lot of us working on campus jobs or different types of ways to just get by, definitely using our biggest asset, our intellectual capital, intellectual property capital. I don't know if that makes sense, intellectual property, to gain money and to be able to use a lot of the skills that we're learning in our classes and with friends to apply to these types of things to even make a better world, definitely is a way to use the engineering problem solving process. And for those of you who are tuning in virtually, here's a panel of the SHPE IIT Executive Board that's eager to answer any of the questions that you have. You can message us on LinkedIn or visit our SHPE IIT website, and we'll be glad to communicate with you about any of the topics that you've heard tonight. But yeah, just to reiterate, scientists discover the world that exists and engineers create the world that never was. So should be proud to be an engineer, somebody who is looking out for the good of future generations. And also think about where you are in the engineering problem solving process when you're applying to an internship or job. If you're in the create phase, or if you're in the planning phase, or if you're in the improvement phase, there's all different types of engineers out there. And knowing your place in the process can help you impact the company that you're working for and help you have a greater picture of how you are connected to a company's goal or a global problem that's being solved. So thank you for watching this presentation. For those of you virtually, thank you for coming today. For those of you here tonight, I just wanted to give a shout out to SHPE Region 6 and their Engineers Week. There's other events this week. We have some other chapters in the Chicago or Region 6 area that are going to be presenting, and Thursday our big Noche de Ciencias. So take advantage of that and come out to them and support. We're always here for you, and thank you again for taking the time to view this presentation. Have a great one.